In this question, you've been stated that an object has acceleration of t squared minus t, and we'll say those units are in meters per second squared. You're given that velocity when time is 1 is 2, and position at time of 0 is 3. What is the position at time equals 2? So we're trying to go from acceleration to velocity to position. And so those are going to be two integrals. We'll start by integrating acceleration. So our velocity at any time t will be the integral of acceleration dt, and we're going to start at time equals 1 and finish at some time equals x, and we have to consider that we're starting at a velocity of 2. So when I integrate t squared minus t, I'll get my velocity at some time, anytime. We're going to say our dummy variable is x now. Will be this starting position, or a velocity of 2, plus the antiderivative of t squared is t cubed over 3 minus t squared over 2, and this needs to be evaluated from our starting value of 1 to our final time of x. When I do that antiderivative, when I plug those limits in, I have 2 plus x cubed over 3 minus x squared over 2 minus, I'm going to plug in 1, so we'll have 1/3 minus 1/2. Well, 1/3 minus 1/2 will be a negative 1/6, and because I'm subtracting a negative, that's going to be plus. So we really have 2 plus 1/6 plus x cubed over 3 minus x squared over 2. That's my velocity at any time x. Well, if I want to then go from there to position, my position at any time t, now I'll use t as my we'll try to end up with t as our variable, so we'll say x is going to be the dummy variable here. And we'll go from 0 this time to the time we want of 2. Why did we start from 0 this time? Because that was our initial time that we know position at. And we're going to add 3 to all this, because that is our starting position. So we've got 3 plus the integral from 0 to t of 2 1/6 plus x cubed over 3 minus x squared over 2 dt. When I find this antiderivative, 2 1/6 is the same as 13 over 6. So we'll have 13 over 6t. Actually, it's going to be x. Plus x to the 4th over 12 minus x cubed over 6. And we're going to evaluate this from 0 to t. And we'll add a 3 on top of all of this, because that's our initial value. Now we plug in some numbers, and this t, our final time, is 2. So as I evaluate this, we're going to have 3 plus 13 times 2 over 6 plus 2 to the 4th over 12 minus 2 to the 3rd over 6 minus all of this at 0, and since these are all polynomials, that's just going to be 0. And evaluating this without a calculator gets 22 over 3, or 7 1/3. That is our final position at time equals 2.